Okay, today we're going to be solving matrix equations using the inverse method. Now, I would strongly suggest, and we're doing all these by hand, another video we'll do them with the graphing calculator. We're going to do these by hand. I would strongly suggest that if you don't know how to find the inverse of a 2 by 2, go back and watch that video. Okay, we're not going to spend a lot of time talking about that here. Just going to assume that you know it. Okay, so go back and watch the inverse of a 2 by 2 because we're going to be applying that here. Okay. Okay, so the way you should look at this is you have some matrix being multiplied by matrix X, and that gives you this matrix here. Okay? And we know for matrices, this is a 2 by 2. Okay? This is 2 rows, 1 column, 2 by 1. So our answer, remember the numbers have to be the same on the inside, and then the number on the outside is your result. So this has to be a 2 by 1 matrix. Because now these match up, so that means we can multiply them, and our answer will be a 2 by 1. So we're expecting something to look like this. Okay, that's always good. One way that I always look at these, I call this matrix A, this is our matrix X, and this is our matrix B. And this is in the form of A times X equals B. Okay? Now back to like algebra, when you solve the equations and all that, you'd say, oh, if I have to find X, you divide by A. Okay? Well, matrices, it's not that easy. You have to use the same ideas, but you're going to be multiplying by A inverse. So we're going to multiply this guy over here by A inverse. And the reason for that, when these two get multiplied together, they turn into the identity matrix, or just pretty much like 1. So we're left with X on this side. Okay? It's just like if you had 2x, you multiply by 1/2, you're left with x by itself. Same idea here. The only big problem here, we multiplied the left side of x by A inverse, so we have to multiply the left side of B by A inverse. That order is very important in matrix multiplication. You can't do B times A inverse. Sometimes you won't get answers, the dimensions won't match up. So we have to do A inverse times B. This is like our blueprint, our plan that we're going to attack this problem with. And again, multiply this side by A inverse of X, gets multiplied this side by A inverse. If A were over here, then we would have multiplied that side. So again, this is our blueprint to find X. We're going to take the inverse of this guy and multiply it by this. Let's get to work. So A inverse, okay, that's 1 over the determinant of A. Well, that's just 10 minus 6, or 4, times, remember we switch these around, -10, -1, switch the sign. There you go. There's A inverse. Now we're going to take A inverse times B. So A inverse times B is 1/4 times this guy times B. Now, some people distribute that 1/4 when it comes to the inverse. I usually wait till the very end because of this. I'm going to multiply these two matrices together and then distribute the 1/4. No big deal. It's just a scalar multiplication, not violating any laws. So A inverse times B, 1/4. Now I'm going to do my rows by my columns. -10 times 1 is -10 plus 30. So -2 times 15. I guess if you don't know how to do matrix multiplication, look at that video. Okay. Then this row by that column, -3. -1 times -15 is a positive 15. Okay. So A inverse times B equals 1/4. I can make these look nicer. That becomes 20 and 12. Now I can distribute the 1/4 into both of those. So A inverse times B, remember that's just what X is equal to. So X equals 1/4 times 20 is 5. 1/4 times 12 is 3. There you go. There's the, so that's the matrix that you multiply this guy by to obtain 1 and negative 15. Okay? Okay. I want you to pause the video and try to do one on your own, and then turn it back and see if we get the right answer, or the same answer. Okay, let's try this one. Okay. Try your best. Pause the video, try it out. Welcome back. Okay, let's look at our blueprints again. So here, usually I just go left to right when I call. So this is A, call this matrix A, equals matrix B times X. I got to get X by itself, so I have to multiply by B inverse. In order to get rid of it, got to put the B inverse over here. I multiply to the left of X, so you got to do the same here. Okay? So B inverse times A is going to give me X. So this is our blueprint. This is the plan we're going to follow. Okay, let's first find B inverse. Okay, that's 1 over negative 10 minus a negative 8. I'm going to be tricky there. It's a negative 2. Switch these up. Switch the sign. Okay. Okay, now we do B inverse times A. I'm going to keep again the negative 1/2 outside here. B inverse is 5, 1. Multiply that by A. Okay. Again, I'll worry about this thing later on. Okay, cool. I'm going to multiply these two together. Take your rows by your columns. 5 times negative 9 is negative 45, plus a 31. So B inverse times A, 1 over negative 2. And I guess in the beginning you could have looked at what the dimensions would be on this one. That would have been smart to make sure you could actually multiply. But it's okay. Anyway, negative 45. So what, negative 14? Okay. Negative 8 times negative 9 is a 72. That gives us a 62 negative. So 72 plus a negative 62, we get 10. Okay. Now you can just distribute the 1/2. And remember, B inverse times A is the same thing as X. So X is going to equal 7, negative 5. Okay. So not always is it going to be a nice 2x1. It could be a 2x2, whatever it is. If here you had like a 2x2 here, you're doing your rows times columns, same exact idea, and then just distribute at the end. I think where people start to kind of struggle with is they distribute the 1/2 first. 1/2's not that bad, but they distribute it, and then people struggle with fractions, with their arithmetic. Rough days. So make your life a little bit easier. Just multiply these two matrices together, and boom. Scalar multiplication doesn't matter. Matrix multiplication, the order does. Scalar multiplication, yeah. Okay, hopefully that helped out. One of the future videos, we'll be doing all this on the calculator, and then we could attempt some 3x3s.